Welcome to the Math Record. Today I'll be going over the last two inverse trigonometric derivatives, inverse secant and inverse cosecant. Let's start with inverse secant. So secant of inverse secant of x is equal to x. So using the same procedure, derivative of the left side. So the derivative of secant is going to be secant and tangent of x. So we need to substitute our inverse secant into both these x's. So this is just going to come out as a really long equation. Secant of inverse secant of x times tangent inverse secant of x. Multiplied, because still need to do a chain because it's a function inside a function. So that gives us our derivative of our inverse secant of x, which is what we're looking for. And then derivative of x is 1. So from here, what we kind of notice that's different about this compared to what we did in the past two videos is that now we have two functions. So in that case, now we have to keep track of the positive and negative signs, because in the previous cases, if it was positive on one of them, it's just going to stay positive. If it was negative on one of them, it's going to stay negative because there's only one of them. But this time, if this is negative, we don't know if this is negative or positive. So what we had to do is that we need to keep track of the sign, because if this is negative and this is negative, it might be positive at the end. So we don't know that. So what we had to do is to figure this out using a picture. So secant works the same. Inverse secant works as the same thing as inverse cosine, which only works in the first and second quadrant. Okay. So let's call that theta, and 90 degrees. So secant is the hypotenuse over the adjacent. So since it's x, it's going to be x over 1, and that's going to be x over 1. So what we're going to have is the hypotenuse here is going to be, using the Pythagorean theorem, x squared minus 1, take the square root. So this is just going to x squared minus 1, and square root x squared minus 1. Okay, so let's put a negative 1 here. So then if we plug in an x value here, some value here, that means secant is negative, and if this was positive, it's going to be positive here. So it depends on its coordinates. As I said earlier, there's going to be a positive and negative sign. So let's keep track. So we have a tangent here in the first quadrant, secant in the first quadrant, tangent in the second quadrant, and secant in the second quadrant. So if we take a tangent in the first quadrant, it's going to be positive divided by positive, because they're both positive. The x and y are both positive here, the x and y coordinates. That means this is positive. Now the secant, it only cares about the x, and the x is positive in the first quadrant, so it's going to be positive. Okay, so overall, a positive times a positive is a positive. Okay, let's work with this one. In the second quadrant, our tangent is a positive y and a negative x. So that's going to divide out to a negative. Secant only cares about the x, which is negative. So negative times a negative is going to give us a positive. So no matter what x is, positive or negative, it's always going to come out as positive. So we need to keep that in mind when we simplify this. So what's secant of inverse secant of x? Well, that's just x. Well, what about tangent of inverse secant of x? Well, tangent is just opposite over adjacent. So that's square root x squared minus 1 divided by 1. So that's just square root x squared minus 1. And we immediately see from here the x times square root x squared minus 1, it's positive or negative depending on what x is, because this absolute value, a square root, is always going to be positive. So that means this, if it's negative, is going to make this entire thing negative, which is something we don't want. So that means we had to add an absolute value here. And that's why the functions for secant and cosecant are going to be weird, as I'm going to show later on. So that means the inverse secant derivative is going to equal to 1 divided by this thing, which is what we had simplified as x, as we said, it had to be a square root x to make it positive, and a square root x squared minus 1. And that is our first formula. Okay, now let's work with cosecant. Cosecant and negative, the inverse cosecant is equal to x. The derivative of cosecant is negative cosecant and cotangent. Plug in our original x value, which is inverse cosecant, times cotangent, inverse cosecant. As usual, we have a function inside a function, so we have to chain it. So the derivative of our inverse cosecant, which is what we're looking for. And then the derivative of our x is 1. So let's draw a picture again, but this time we're going to have to think about inverse cosecant. Cosecant works in the first and second quadrant like sine. So, I mean first and fourth quadrant. So first and fourth. So theta, theta. So cosecant deals with hypotenuse over the opposite. So hypotenuse is x. And our opposite is going to be 1. In this case here is going to be negative 1. So that gives us our positive x and our negative x, because x divided by negative 1 is negative, x divided by 1 is positive. So it's going to give us both cases, if x is positive or negative. Okay, so what we have here, we do the same thing. Now we need to find our x value, which is our length. So using the Pythagorean theorem, x squared minus 1, take the square root. So this value is just square root x squared minus 1. Okay, so as we could simplify here, cosecant, inverse cosecant, that is x, negative times that x is negative x. And then cotangent, cotangent is adjacent over hypotenuse, so that's square root x squared minus 1 divided by 1, which is just square root x squared minus 1. So let's keep track of the signs now. So we have our cosecant, and we have our cotangent, cosecant and cotangent for quadrant 1 and 4. So cosecant deals with only our y value. Our y value is positive here. And cotangent deals with both of them. So this is positive and this is positive. So positive divided by positive is positive. So overall this is positive. Okay. And now let's deal with this value. So cosecant in this coordinate is negative. So this is negative y value. Now the cotangent in this case is negative here and positive here. So that's going to be positive divided by a negative. So it's going to be a negative. So negative times negative in this case will also give us positive. Same case with secant, we have positive in both of them. And what we did was that we need to add an absolute value. So we had to add an absolute value for x. And it's not absolute value of this because this was outside of our equation. So it's actually right here. So it's similar to what we did for our secant. Okay, so let's delete this so I get room to work with my new equation. So that means our inverse cosecant of x, the derivative of our inverse cosecant of x is 1 divided by, we have a negative absolute value of x, square root x squared minus 1. And I don't like the negative on the bottom. I usually like to move it to the top. So it's going to be negative 1 divided by the absolute value of x times square root x squared minus 1. And as you see, similar to how inverse sine worked with inverse cosine and inverse tan worked with inverse cotangent, it's the same case with inverse secant with inverse cosecant, where one is positive and one is negative, and the denominators are the same. In this case, I am not going to work with the example for this because it's going to be a little bit more complicated. So I'm just going to leave you with these two equations. Well, thanks for watching, and I'll see you at the next math record.